This lesson, we're going to be talking about higher order derivatives. So first derivative, second derivative, third derivative, however many you want to take out. There's meaning behind each layer of this. So just kind of that basic look of if you're talking about the first derivative, you're talking about an f prime of x or a dy dx. If you're going to do the second derivative, you're going to be taking the derivative of the derivative. And so we would symbolize that with an f double prime or a d squared y over dx squared. Okay, so let me talk why that happens. And so if you have a derivative already happening and you take the derivative of that, you get a d squared y and then two dx's. It's kind of the math on it. So you're doing the derivative of this with respect to x. And so that's kind of where that comes up. All right, so third derivative is you're doing the derivative of the second derivative. Or you might see it symbolized as d3 y over dx3. And then if it was the nth derivative, you could have the fourth derivative, fifth derivative, whatever it is. It's n number of tick marks, or d n y over dx to the n. Usually it kind of cuts off after the third derivative because there's definitely meaning behind these first three layers to it. So they're asking you to do the third derivative. We're going to do the first derivative, which is going to be the power is going to multiply. So that's going to be a 9x squared minus 5. And then if you did the second derivative, then you're going to pull the power down. So that's going to be an 18x. Derivative of a constant is 0. That's why that 12 went away as well. So then you're just left with 18x. And then if you did the third derivative, then you're just going to get an 18. All right, so there's your third derivative of that one. And if you're looking to do this third derivative of this one, you have, we'll say it's y, so we'll say y prime. So there's your first derivative. Derivative of 3t is just going to be 3. Power of 1 comes in front, that turns to 0. And then plus the derivative of an exponential is itself. So it's just going to be 2e to the t. Nothing changes. And if we do the second derivative, derivative of the 3, derivative of a constant is 0. That goes away. And this doesn't change again. And then third derivative, you're still left with this. So it just kind of goes on and on. All right, so that was just talking about how we find first derivatives, second derivatives, third derivatives. Eventually, we'll talk about the meanings behind them, but basically, can you just perform the operations?